Hey, Topping Life's Math and History, and we're gonna try to find the range and the domain on a line on a graph. And this is all about functions. So, when you are trying to find the domain and the range of a function in its equation form, the x is going to be called our domain, or what we insert for x. Our range is going to be our result, or our output, what we get after we insert for x. And every x that you see in an equation and you insert something, then that has to be represented as x as well. Like if I put lucky 7 in here, lucky 7 has to be in here as well. But how do you find the range and the domain of this kind of function? Well, it does pass the vertical line test. When you have a pencil or a line, swing side to side, and it's telling us that this is a function because functions can only have one solution per input. You might think that this function is going to have the domain and the range as like whole numbers, like 3, 7, 14, 10. But the thing is that any number that lands on the line or any number that follows a line can actually be an answer as well. So if we try making a lot of whole numbers, there can also be decimals as well, like 6.5. There is an infinite number of numbers between 0 and 1, starting out with 0.999999999 repeating. If we try to put out every number and say that was the domain, for example, then that would take too much time, and that would overload the paper, and you would keep going on forever and ever. So that's why we're going to have the domain and the range as an inequality, because the lines are being included, the numbers inside the lines. So, in the earlier part of the video, we said that the domain is going to represent x, or our input. So we're going to take a look at the x-axis. We're going to take a look at 4 right here and -4 right here, because that is where the line ends and begins with. It doesn't go past 4 and doesn't go past -4. So we're going to get an inequality as x, because x represents the input. And we're also going to say -4 and +4. But since we have a line connecting from here all the way to there, we're going to have an inequality that is -4 is less than or equal to x, because x is pretty much the line right here. X is pretty much the line from -4 to +4. So any number that you insert in for x should be between, or at least -4 and +4. And that will work as a function right here. So that's what x represents. But it also has to be less than or equal to +4, because we said earlier, the line cannot go over 4. It can be 4 because it's included, but it cannot go over 4. So this is going to be our domain for our function, an inequality. This will save us some extra time instead of placing and adding all the numbers on the line, because that would take a lot of time and that's sort of a waste. But wait, how do we find the output? How do we find the range? So instead of using x, we're going to use y as the range, and your answer will still come out as an inequality. If you ever heard the equation y equals mx plus b, mx is going to be your input or domain, while y is going to be your output or the result of your equation, what you put in for x. Y equals 2x plus 1, and let's say 3 is in for x. 2 times 3 is 6 plus 1. You get an answer as 7, so y is going to be your output. To find the range of y, what we're going to take a look at is where the lines on the top and the bottom meet, and the function is going to be limited to in between those lines. So it looks like the top line is going to be 6, and the bottom line is going to be -5. So what we're going to be doing is we're going to go from the bottom and rise up to the top to the sky. We're going to say that -5 and 6, we're going to say that -5 is going to be less than or equal to y. Any number from 6 to -5, -4, -3, -2, and so on, any number on that line that fits the criteria of here and here will be accepted for y. It's going to be less than or equal to 6. No y on this number line can be more than 6. If we write 7, then it's not going to count because the line doesn't reach 7. We're just putting limits to where the function can end up to. So that is how we find the domain and the range of our function. Well, a line function. You will see these in inequalities. But what happens if you don't see a line function and you just see a jumbled mess of dots all over a graph? You may think that we will be using an inequality. Well, no, because there's no line connecting them. These dots are just all alone in their places. So we're going to say that the way we find the domain and the range for this kind of problem is we're going to normally be using whole numbers like 3, 7, 14, 10, because since there's no line included, that means that if the number was here, that's not included because there's no line connecting from there to there. So we're going to graph these normally and find the domain and the range. So you probably know how to graph if you're in high school. So we're going to say 3, 2, 3, 2. Then for this one, we're going to say -3, +2. And for this one, we have -3, -2. And for this one, -5, -5. And the last one up here, +5, +3. So those are the coordinates of those dots that we placed around. And to find the domain, we're going to be using something that looks like this. So we're going to look at every x value of the coordinates that we placed. The x values are going to represent the first number that appears on your coordinate. So 3, 5, -3, -3 again, and -5. That is going to be our domain. That is our x value, what we insert and for x. But how we find our range or what we get? We're going to look at the second part of the coordinates. Look at the second number and place those numbers onto your range right here. So we have -5, 2, 2, wait, this is a -2, 2, 2 again, 3. So -5, comma, -2, comma, 2, comma, 2, comma, +3. So that's going to be our range. And this is how you find the domain and the range of a function that has no lines but isolated coordinates. Thank you for watching Tao Penalized Math Industry. Like and subscribe, and I hope this video has helped you.